June 29, 1995, Seoul, South Korea, 5:57 p.m. The south wing of the Sampoom department store, a 5-story building on top of a former landfill in one of the wealthiest districts in the city, collapsed into its own basement in roughly 20 seconds. 502 people were killed, 937 were injured. The building had been open for 5 years. On the morning of the collapse, structural engineers had inspected the roof, found cracks wide enough to fit a fist into, and told the owner, Lee Jun, that the building was at imminent risk of failure. Lee closed the 5th floor. He shut off the air conditioning. He did not close the store. He did not evacuate the customers on floors 1 through 4. Lee Jun himself left the building as a precaution. The customers stayed. 5 hours later, column 5E, the most overloaded structural column in the entire building, sitting directly underneath 3 15-ton air conditioning units that had been dragged across the roof 2 years earlier because the neighbors complained about the noise, separated from the 5th floor slab, and the south wing of the Sampoom department store ceased to exist. Last month, we covered cults, systems that exploit trust. Today, systems that exploit cost-cutting. This is a video about 4 buildings that collapsed, not because of earthquakes, not because of engineering limitations, not because the science didn't exist to prevent it. They collapsed because someone was warned, and someone decided that the warning was less important than keeping the doors open. We're going in order of escalation, from "he knew that morning" to "they knew for decades." The Sampoom department store was never supposed to be a department store. The original design was a 4-story office building. Midway through construction, Lee Jun decided he wanted a shopping center. The architects objected. The structure couldn't handle the load. Lee fired them and hired ones who would make the changes. He added a 5th floor that wasn't in any approved plan. He removed support columns to make room for escalators. The concrete was substandard. The rebar was insufficient. The flat slab construction meant that if one column failed, there was nothing to redistribute the load. The building was a countdown from the day it opened. By April 1995, cracks had appeared in the 5th floor ceiling. Management moved merchandise to the basement, not to protect customers, but to protect inventory. When the cracks worsened in June, engineers were finally called. They said the building was at risk of imminent collapse. Lee asked how long repairs would take. Months. Lee said the store couldn't afford to close on such a profitable day. He left. The executives left with him. The customers stayed. After the collapse, South Korea surveyed its high-rise buildings. 2% met building codes. 2%. The Sampoom wasn't an anomaly. It was the one that fell first. August 14, 2018, Genoa, Italy, 11:36 a.m. A 200-meter section of the Ponte Morandi, a bridge that carried roughly 25 million vehicles per year as part of the A10 motorway connecting Italy to France, collapsed during a rainstorm. 43 people died. The bridge was 51 years old. It had been designed for a 50-year lifespan. Nobody would call a 51-year-old bridge collapsing a total surprise. But here's what makes the Morandi collapse a member of this list. It wasn't that nobody knew. It was that everybody knew. And the documentation trail is so complete it reads like a legal filing written before the event. The bridge's designer, Riccardo Morandi, had used pre-stressed concrete stays instead of steel cables. The concrete was supposed to protect the internal steel from corrosion. It didn't. By the 1990s, corrosion was visible. In 2011, the highway operator produced a report describing intense decay. In 2012, Genoa's Business Federation chief publicly stated the bridge could collapse within 10 years. In 2016, Italy's transport minister was informed in parliament multiple times. In 2017, a confidential university report flagged severe anomalies in the stays of Pillar 9, the exact pillar. In February 2018, measurements showed a 10 to 20% reduction in the tendon's cross-section. A crack appeared in the road 14 days before the collapse. In May 2018, a €20 million repair contract was announced. The bridge collapsed before the bids closed. A Morandi-designed bridge in Venezuela with the same system had already suffered cable failures in 1979. The precedent existed. 59 people went on trial. Prosecutors described the bridge as a, quote, 3 where, quote, 4. The trial question wasn't whether anyone knew, it was why knowing wasn't enough. April 24, 2013, Savar, Bangladesh, 8:57 a.m. The 8-story Rana Plaza, a commercial building housing 5 garment factories, a bank, and several shops, collapsed in under 2 minutes. 1,134 people were killed. Roughly 2,500 were injured. It remains the deadliest garment factory disaster in history and one of the deadliest structural failures of any kind in the modern era. The building was constructed in 2006 on the site of a former pond by a developer named Sohail Rana, who had the political connections to acquire permits that should not have been granted and the resources to ensure inspections that should have happened did not. The upper 4 floors were built without permits. The building was designed for shops and offices, not for factories with heavy industrial sewing machines, generators, and thousands of workers. The day before the collapse changed everything, or should have. On April 23rd, large cracks appeared across the building's walls and support columns. Workers refused to enter. A local television crew filmed the damage and broadcast it. The building was evacuated. Engineers inspected the structure and concluded it was unsafe for occupation. Police ordered it closed. That night, Sohail Rana told the media the building was safe and that workers should return the following morning. Factory managers reinforced the message. Some threatened to withhold a month's wages from anyone who didn't show up. The bank and the shops on the lower floors stayed closed. The garment factories on the upper floors, the ones with the heaviest loads, the most workers, and the industrial generators that shook the building every time they switched on, reopened. By 8 a.m., roughly 3,500 workers were inside. When the power went out, a routine occurrence in the area, the generators kicked on. The vibrations ran through a structure that had been declared unsafe less than 12 hours earlier. 57 minutes later, the building was gone. June 24, 2021, 1:22 a.m., Surfside, Florida. The eastern wing of Champlain Towers South, a 12-story beachfront condominium built in 1981, collapsed while most of its residents were asleep. 98 people were killed. In 2018, an engineering assessment identified extensive concrete deterioration and water damage in the pool deck. The waterproofing had failed, allowing water to corrode the steel reinforcement in the support columns. The report recommended urgent repairs. The Condo Association approved a $15 million remediation project. By June 2021, the main structural work had not started. Federal investigators later found the pool deck's concrete was weaker than code required. Steel reinforcement was misplaced or missing. Planters and pavers had been added over the years, increasing the load on an already compromised structure. 22 days before the collapse, photographs showed visible vertical movement in the slab above the most heavily loaded column. When the pool deck gave way just after 1 a.m., the progressive collapse took 12 seconds. 98 people died in a building that had a report, a budget, and an approved plan, and a 3-year gap between approval and action. 4 buildings: Seoul, Genoa, Savar, Surfside, a department store, a bridge, a garment factory, a condominium. 4 different countries, 4 different decades, 4 different structural systems. The pattern is not engineering. Engineers identified the problems in every single case. The pattern is the gap between knowing and doing. In Seoul, the owner left the building and kept the customers inside. In Genoa, the decay was documented in Parliament and the repair contract was still in procurement when the bridge fell. In Savar, police ordered the building closed at night and workers were sent back in the morning. In Surfside, the report sat in a file for 3 years while the concrete continued to corrode. The engineering wasn't the failure. The engineering worked. The reports were written. The inspections were conducted. The warnings were delivered. The failure was the moment between receiving the warning and deciding what to do about it. And that moment, the one where someone weighs the cost of closing against the cost of collapse and picks the number that's smaller today, that's not an engineering problem. That's a human problem, and it has no building code. These buildings collapsed. The ones in the next video are still standing, with people inside.